Do you want to know which one is the best ROS robot for your purpose? Then stay here. This is the ROS Developers live class and we are going to ROS. Let's go! Hello guys, how you doing, ROS developers? So I don't know if you are seeing me, I don't know if you are hearing me on the YouTube channel, then it says that it's not showing, but here everything looks like it is correct, and we are transmitting here and showing all the data. So I don't know at present what is happening here. So let me see. Give me some feedback if you are receiving this in the okay, so looks like it appeared right now there. So this is kind of stupid, but this is what we have. So hello all the ROS developers around the world, and welcome to a new ROS Developers live class. And happy to be back. We have been some weeks out of the normal live classes because we had so much commitments on top, but now we are back, and then we are ready to start teaching something about ROS every Tuesday. And today we are going to do a very special live class, which is about identifying a set of robots that you can use for your ROS projects, for your robotics experiments, learning, teaching, research, all those fields we are going to cover. And so basically today we are not going to practice on ROS. We are going to see those ones and provide you with the names and the company names so you can buy them afterwards in case that you're interested. But before that, let me check the chat and see if everybody is there ready and following. So we have Matthew here. Yay! Yes, Matthew. Lagan Kapoor. Oh, Lagan, so long time that didn't see you. So happy to have you here back again. Then Vasily Popov, Evangelos, Pigeon, Wudong Hu, Mathiek, and Dean Sir, Nalbant, Brian Lerner, and then Drasti Patel. Drasti, how are you? Nice to see you here again. And then Mathiek, I already mentioned, Brian Lerner, and and some other people that are there. Dinser, Dinser Naiban, I already said. So thank you very much, all of you, for being here. I had seen that you already have started to ask some questions there on the chat, but couldn't answer your questions because I was trying to solve the issues here. But as a good ROS developer, as an engineer, so we solve it, and here it is. So I deserve my hot coffee here. Great, so let's go and let's start with the list of ROS robots that we should buy. And then I will receive some questions by the end of the talk. So you can keep asking the questions, but it's better if you stay until the end because otherwise it will be kind of a mess on the chat. I will try. So if there are no many questions at the same time, so I will be keeping an eye. And in case that you want to ask something specific about one of the slides that we have there, then try to jump it. And then I will try to answer on the spot. And thank you, Ali, because he says, welcome back. Thank you, Ali. Also happy to be here. And then let's go. Then let me see here on my screen. So go to the ROS Robots presentation, and the list that we are going to do, well, in order to answer that question, which ROS robot do I have to buy? It depends. Of course, it always depends. And what depends on? So it depends on your purpose. If you are going to use the ROS robot for learning, for example, or you are going to use it for teaching, or you are going to use it for research. So it depends on those things, which type of robot is better for you or not. Then also it depends on the budget. How much would you like to use to buy the robot, and also in the interest that you have. So in the interest, what I mean is if you want to deal with the hardware or you want just to deal with the software, with the programming thing of that robot. So many people, they say they are not interested on trying to repair if there is an error in the robot, in the mechanics or the electronics of the robot. or a sensor is broken, so they don't want to deal with that. So they do prefer a closed solution that they are going to program just straight, so they can switch it on and start programming. So that's what I mean by interest, if you are interested on building by yourself or not. So based on those the conditions, let's say the purpose, the budget, and the interest, we are going to review all the robots, and I'm going to show you for which purpose I would use those robots. Of course, you can use one robot for any purpose, but based on some criteria, so I think that some robots are best suited for some purposes or some others. So we are going to see in a minute. Then another thing is the criteria that I selected in order to put all those robots there on this list is that the first one is that they are robots that you can buy. So maybe you will see a lot of robots, hey, this ROS robot that I built, this other ROS robot that I built there. So I'm not taking those, let's say, amateur robots into account. I'm not taking also robots from companies that they cannot serve you. They cannot provide you with a robot if you order. So those are robots that you can pay the money and then receive a package at your home, at your lab, and have the robot, either to build it yourself or already built and just to put it out of the box. Then the criteria is that the robots also have to be you must be able to use them for your own purposes. So that means that it's not a ROS robot that works on a warehouse, for example. So it's not this kind of robots that we are going to talk. It's a robot that you buy and then you want to build a purpose for that robot. You want to program it. You want to do some stuff on that robot, not to put it to work into a warehouse or into an airport or into whatever place. So this is the second criteria. And then the third criteria is that they have to run ROS, of course. So they had to run ROS, but also they had to be, this ROS support has to be supported directly by the company that builds the robot. Otherwise, if there is an amateur repo that you can apply to this robot and then it will work with ROS, then I will not take that into account, because those repos, they do not evolve at the speed of the robots. So it has to be the company behind the robot that is creating those ROS packages, either because the robot by itself, off the shelf, it works with ROS, or because they are providing some extra packages that you can download and then apply to the robot directly. But they have a kind of maintenance or stability against the evolution of the real hardware and the evolution of those packages. So those are the criteria. And also would like to say a disclaimer that we have not been paid anything in any way by the robots that appear there. And then, so this is just what I think. Actually, there are some robots that I would like not to prefer to put it there for several reasons, but I think that would not be fair. That would not be fair because my personal preferences don't have to be taken into account. And so I think that this is good information for you. So it has to be useful for you. So this is the disclaimer. So let's go. Let me have a look into the chat and see if there is something. So I see here, thanks a lot. Tatabot3, hey, personal preference, build your own, cheaper and more of a learning process. Yeah, so that's the first. This is Fade Illusions, Fade Illusions, that says that he would prefer to have a robot that you do it yourself. So this is the first. This is the first option that we are going to see here. Do-it-yourself robot. And then we have here, let's talk about PR2. Lagan, sorry Lagan, we are not going to talk about PR2 because PR2 is kind of dead already. So I would be interested in industrial robots using ROS as well, but maybe for another time. Yeah, so we are not going to talk about industrial robots because the criteria that we are going to talk here, it's about either learning, teaching, or research. And then those industrial, if you consider those more for the companies, for building, for using those robots directly into a company. So we are not taking this purpose into account here today. Then Marcus, hey Marcus, how you doing, man? Nice to have you here. He says, based on my experience, I would recommend to buy articulated robot like industrial robot, 6 axis or less. One should understand robotics and program. I recommend Area 1 supported by ROS. Great. Now only KUKA, ABB, and well, so you are doing a lot of stuff there, and you are discussing between you. That's great. Keep doing it. That's great that you interact between each other. So let's go now to the list of do-it-yourself robots. Those are robots that you are going to build by yourself. So basically also you have even to, in some cases you have to even use the soldering machine in order to solder some of the cables and so on. But everything is packaged and provided to you. So you get a box with all the components, and then you have to build more or less in a more difficult or less difficult way. So the first one, I would like to talk about the linear robots. The linear robots is, you can find them at linearrobots.org. It's a series of robots that you can build, and they are created by Juan Jimeno. I have put here just an example of them, and it's a robot, it's a wheel robot, a differential drive wheel robot equipped with a laser. So it's very simple robot, but you can do a lot of things with this robot already. Actually, you can do perfect navigation, you can explore all the components of navigation in a wheel and mobile robot. I think that based on the price and the size of the robot, I think that is best suited for learning. Learning means that you want to learn, so you want to buy this robot in order to practice. Like there was one guy here that was mentioning, that is, let me see, is okay, so many things there. I cannot see. Well, there was one person on the chat that was talking about, I want to build my own and learn. So that's one specific example, and also can be useful for teaching. So I tick those two, the learning and teaching. And I think that we have, let me check what is happening here. Okay, so this is for learning and teaching specifically. Yeah, it's stopping, so I'm sorry for that. I can do nothing. I don't know, we test everything and it only starts to fail when we start the transmission. But anyway, let's continue. So this is the linear robot. And then another one that we'd like to show you is the DokiBot. The DokiBot, it's a robot created on a project that is called the Dakitown project, and it's an amazing project where they have built a complete small-scale city of roads, and they use those robots on those roads. So the robots are very, very simple. They try to make it as low price as possible, and they contain just a differential drive with a Raspberry Pi, and then they have a camera. So they don't even have a laser or something similar. So they have a camera, and then you have to control the behavior of the robot by using only those devices. So managing the navigation skills of a wheel robot with a camera is a lot more difficult than using a laser. So that's very nice and challenging. So this is very low price, is good for learning and for teaching. So also I have included in this case that is very good for research, in the sense that by building this city in your place, then you can start making research about collaboration between robots, or more than collaboration, coordination between robots, based on the different encounters that the robots have to, they will suffer by going around those roads and finding themselves into the crossroads, and then they have to manage the turns and so on. So it's quite interesting. They have done some research based on those robots. That's why I have included there. Then I have included also the robot that we have built at the construct that is called the IgnisBot. So the IgnisBot is a very small robot also, like this. And then it is based, the difference between the others is that this one is based on the NVIDIA Jetson Nano. So that allows you to have some extra power, GPU power, for doing deep learning on a very small robot. So that's the difference between this one and the other two. And we use the JetBot robot as a base, and then we modify the robot to include this camera that can move at different angles, and also the robot itself includes a tail that can wag like this in order to provide you with some feedback. So we consider this for learning and for teaching. For research, I think it's very too small, I think. Okay, so those are the 3 robots that I would recommend for doing yourself. So you want to start working with ROS and you want to start from zero. You want to build your robot. You want to take all the parts and make it complete, and then create the drivers for the robot. So those robots, they do provide you the code already made, but you can understand what is happening in there. So how is the software communicating with the hardware, and how is it doing it by using ROS topics and services? So those 3 are 3 examples. I don't know if you know more examples. I will be happy to hear if you know more examples of these kind of robots, because I have been searching but haven't found them. Then let's go to the small wheel robots. So wheel robots are very common and very popular, because in robotics what we want more, what we are more interested is on making the robots move around. So for that, the easiest way is to provide the robots with wheels. Then the problem with that is that the bigger, so the more difficult to build and to have. So that's why the previous ones, and more expensive, the bigger the robots. So that's why the other 3 are very small ones. Then we move to another range that is also a small wheel robots, a little bit bigger than the ones that I presented before, but that they are already made. So you can buy them and you can directly start working with them on ROS. And the first one is, of course, the number one of all the robots, that is the Turtlebot 2. So it's been created many years ago and it's still number 1. So every lab in robotics, they do have this robot in their labs, and they have used for many experiments while teaching with their students and to learn. So you can buy this for yourself to learn. You can buy, but it's very common that it's used for teaching also. Then for research, yeah, you can use it also for research. It's not common to use it for research because it's very limited in terms of sensors and things. But I mean, if you are creative, then you can. So the things that this robot can do, they have been already done for many years. So basically is to navigate around, avoid obstacles, detect some obstacles, and even the object recognition maybe you can do, or person recognition maybe. So that's the Turtlebot. Then we have as a second option is the Turtlebot 3. That's the next generation. But the Turtlebot 3 is made by a company that is called Robotics. So the Turtlebot 2 is, I don't know, I don't think that it's any company that has the know-how, I mean the patent for that, but there are several ones that are distributing it, so you can search on internet. But the Turtlebot 3, it's a patent from Robotics, and they are distributing also. It's open source design, so that's interesting. And they distribute the Turtlebot 3 in 2 options. One is in 2 configurations. The burger that you can see, on the left, and then the waffle that you can see on the right. And actually you can, as you can see, all the parts, they are filled with holes, so you can attach more things on top of them and then create your own configurations afterwards. But those are the main ones. They usually come with a laser, with a LiDAR, so you can do also navigation directly. And they are especially suited also for learning and teaching. You can do, of course, some research. I have seen some research on reinforcement learning, but it's not the typical case because they are very small. So they are basically for you to learn or to provide to the students so they can practice the basic concepts of robotics. Then on the same line, we have the ROS-Bot that is by company Usarion, and for the same purpose, for learning and teaching. And the ROS-Bot is interesting because I see it as very, very well packed. So it's like a very robust, it's smaller than the Turtlebot 2. The Turtlebot 2, the problem is that it's too big, so it's a little bit difficult to handle there around your space. With the ROS-Bot, it's this size, the robot, and everything is very compact, and you have the laser LiDAR there, you have infrared sensors, IMU, point cloud, cameras, and also on the back you have a lot of ports where you can connect extra stuff. It's quite interesting, that one. And all of them, they work like differential drive robots. So we are going to move now to mobile-based platforms. Let me check if you are asking something. I see that you keep talking on the chat. So I don't know, so I cannot identify any specific question in there, so I see that you are talking between you. That's great. So let's continue with the next stage of robots, that is the mobile-based platforms. So up to that point, we have seen some, we can consider also mobile-based, but when I say mobile-based, it's something bigger, and it's something that you are going to build on top also. You could, I would say, you could build something on top. So the mobile-based platforms, usually, the ones that I'm going to present here also are based on wheel robots. And but the price range, because they are bigger, they are supposed to work on more complex setups and bigger setups. And so the price range is a little bit larger. So the first one that I would like to introduce you is the Tiago base. So it's a robot made by PAL Robotics, and it's a differential drive. It has the typical laser, and it has also some IMUs on top, even speakers and microphones. But so that's basically it. The thing is that is the size. It's a big size, and also it can carry some load. It's nice for doing navigation purposes, research, for doing other research that you may need a base for. So you don't have to build the base, you have it for granted, for example. And then let me see, the next one is on the same line. We have the Velocity by a company that is called Bonubo. And basically they have the same characteristics, I mean, in terms of sensors and also of shape, I would say. So the Bonubo is also prepared for you to mount some stuff on top. And also it's the main aim of this robot is for research. And the same happens with the next one, that is Magni by Ubiquiti. So this is also a differential drive robot with that you can include some sensors. This is optional on the Magni. You can include the laser. It doesn't come by default, by difference like in the other two before. In this one and this one, they come by default, the laser. And in this one, you have to include if you want. But this one, the Magni robot, it's I have seen it. used as a base for building other products on top. And also for building, for example, for doing some research on what's the word in English? It's called about the telepresence. So they have put some iPad on top of it and make the base move around. So you can actually build a ROS product by using some of those mobile-based platforms. It's also a differential drive. Then we have the Summit XL by Robotics. It's also mainly for research. And this robot, it's nice because it's equipped to work on the outside. So you can make it work with this type of wheels. It can work on the outside. This robot has different versions. So you can have the Summit XL robot in the version of indoor or outdoor. The one that you can see on the picture is for the outdoor. For the indoor, you can have with some omnidirectional wheels. So that means that the robot can move to the sides, forward, backwards, in all the directions without changing its orientation. So this one that you can see on the picture is especially for the outdoor because of the type of the wheels. And I have seen it used in some research for agriculture. So using this robot in agriculture, like monitoring some of the grains with cameras, so the robot can move between all the parts of the agriculture part. I don't know how to say in English. So another one, mobile base. As you can see, we have a lot of mobile bases. I think this is the hot spot. So where a lot of companies, they are trying to produce products that are sellable, that produce some profit. And yeah, you can see that there are a lot of companies on this segment of robots. And then we have this one MPO 700 by Robotics, and it's also another robot based on laser that has a laser and is for indoor. And also it's this one. Now I don't remember if this one is omnidirectional. I think it is, but I'm not sure. So they have a lot in Robotics. They have several types of mobile-based platforms, and now I am doubting if this one is the omnidirectional or the other one. So we are going to see this company later in other types of robots. Then we have another mobile-based platform. This is especially suited for carrying packages on top. So you can use for that specific, for example, in warehouses, for doing research in warehouses. And it's this MIR 100, and basically it's another platform. It's larger in order to accommodate more larger packages on top. It also has two lasers, one on each side, in each corner, opposing corner of the robot. And it's very nice because it has a blue light. Well, it has a very nice design. So then having between all of them, we have another one finally, is the Jackal by Clearpath. Clearpath has several mobile bases, but this one is for me the most interesting one. It's also for the outdoors. It has a GPS and the type of wheels, and the traction allows you to move it in rough terrain, so you can use it outside. And it's mainly also used for research, but also is used for building other products on top. Or instead of saying product, let's say solutions. Okay, so solutions I think is better the word, because it's another company that uses this robot to build a solution for a third party that is requesting. So yeah, so that's an outdoor robot. Equipped with a laser, with a GPS, IMU, and yeah, and so on. So this is the list of all the mobile-based platforms that I wanted to show you, that and for which purposes they are used. So mainly, as you can see, they are for research. You can use those for teaching, yes, of course. The problem is that so you have to have a big lab for that. Because they are big robots, and usually the subjects that you use those robots for, they are outside of the class. They usually belong more to the research, to the area where the knowledge has to be pushed in robotics. So that's why they are more suited for research. Also, as I mentioned, they can be used for creating solutions of robotics. So if you are a company that builds robotic solutions for third-party ones, then you can use those products, those mobile-based, to build your own solution on top. Then let me check if there is any question in there. And then we have a question here, it says from Bharat, that says, any learning robot that can use Android phone as its CPU? Yes, there was one. There is one. I didn't put it here, this one, but there is one. And I don't remember. Let me check it. That's a very good question. That's a very good question. So, but that works on ROS, that's not so sure. So there was one that Google, by using Cartographer on a phone, Cartographer, in order to build a map, he was able to control a small mobile base based on that phone. But they have closed this line, the Cartographer. So actually the cloud robotics and the robotics part, Google has closed it. So I think that this is not available anymore. Yeah, so I should check for that. So I will check for that. Then what else? There is another question. Any ROS-based? So if you are asking questions, then if you put the question mark at the end, it's easier for me to identify, because otherwise there are a lot of comments there and I cannot identify what is a question or what is a comment that you are talking. I cannot be reading, otherwise it will be forever. Fernando says, any robot able to use NLP and computer vision integrated? So yes, so well, I don't know if to say yes. So there is this Intel RealSense that you can combine this with some software that Intel has developed that is called OpenVINO. So you can combine this Intel Real Sensor that does some part of the processing on board, and this OpenVINO, and then integrate with any of the robots that you have there. So you can put this Intel RealSense on any of those robots, connect to the ports, to their computer or their Raspberry Pi, and then keep doing. So that would be my solution for Fernando. And yeah, and doing degree project with a Turtlebot 3. Okay, so Zip Barthsat says, what about Cogni-Team Hamster? Okay, that's a good question. So I was checking also the Cogni-Team Hamster robot, which is a small mobile base. Yeah, that will be on the section of the small wheel robots. It's a small wheel robot. But so there is a problem, okay? So that's why I selected the ones here. There is a problem of supply. So there is a problem if the company is real or it is not. You know, there are a lot of people that they are saying, yeah, I'm doing this, but then when you try to request them so they cannot deliver. And then for the hamster, I was investigating and I was not sure. So I saw that they have not been updating any on the social networks, on the Git recently, and there is no much information on the website. That's why I discarded that one specifically. So please, if you have more information from the inside, or you bought one last week, so tell me so I can update this information. That would be very useful. Then let's go for the robot manipulators. You were asking, some people there on the chat, you were asking about robot manipulators, because people want to build their robots that can grasp things. So the first interest is to move robots around, so you can have your robot moving around your home. And the second one is to make robots that can grasp things. So those are the robot manipulators. And for the first one that I would like to present to you is the Open Manipulator by Robotics. And this is a small manipulator, okay, this size. And what is interesting here is that it's an open source design, so you can get all the designs for that and download and build yourself. But I don't recommend to do that because it's a lot of work. You are going to spend a lot of time, a lot of money, so it's a lot easier if you just go to Robotics and order there. And this one, because of the size and the limitations that it have, it's mainly used for you for learning, if you want to start learning about grasping things and everything about the kinematics of an armed robot, and also for teaching. Because they are small, you can have several, because of the price also, small price. On the same line, the same specification more or less is this one, Crane X7. It's from a company, a Japanese company called RTNet. And what is interesting is that they have built a series of books and teaching materials around this arm. It's an arm, it's this size, like this, is a 3D printed robot. So its quality, it's good enough for learning and teaching, of course, and especially all this additional material that they have created, and very, very high quality, the teaching material. So I recommend you that if you're interested in learning about manipulators or teaching. And then also we have the Nereo one that somebody was talking there on the chat, that they have one and it has nice, very nice quality also. I have seen it live and it looks very well, very nice, very polite. It's also 3D printed. And yes, it's mainly used for learning and for teaching. It's a small robot like this that you can have here on your side of your laptop and do experiments. You can program with ROS, move it, and so on. Very nice. Then if you want to move to more professional series, then you can go for the UR series of robots that by Universal Robots that you probably already know, of course. Those robots are mainly used for teaching and research, not for learning yourself, because it's very expensive. So you don't need, in order to learn and to do mistakes and do errors, so you don't need to spend so much. You can go to the previous ones and you will have enough. But for teaching, it's quite nice because by teaching, so it's a very high quality robot. And so you can be teaching to your students with a robot that is closer to what they are going to get when they go to an industrial robots. And also, in any case, the universal robots, they are used in many industrial small factories, let's say, for small parts, and also is used a lot in research, either by the robot itself or by attaching it to something else, like a mobile platform or, I don't know, another robot that needs to do something. So the only problem that they have with this robot is that it doesn't contain a gripper. So an arm robot without a gripper, it's a pain. So you will need to buy the gripper separately from another company. They don't sell the grippers. They don't produce the grippers. Then recently Kinova had a robot arm that is called the Jacko, that probably you already know. But recently they have released this new version, and my understanding, they are going to remove the Jacko versions in the next months or years. I don't know exactly the time, but they want to bet for this new version, which is the Gen 3. The Gen 3 incorporates an Intel RealSense camera style on the wrist, so that is very useful. So you get the perception attached to the end effector of the arm. So you can, when you move, you can see what you are going to grasp or act on. Then this robot also is not used for, so it doesn't contain the gripper. So you have to add an extra gripper from another third-party company. And given the prices of those, yes, again, it's for teaching and research. Then the Panda by Franca and Mika is another one in the series. What I like of this one is that it already contains the gripper. So it's one on the line of the more professional arm robots, which already contains a gripper. So that's the interesting part. So you buy the same thing. And also this Franca and Mika is the one that is being used by the movie tutorials to teach you how it works. So on the tutorials, you will see that they are using the model of the Panda robot, and it's quite interesting. So you can see that it works with ROS. And finally, as a manipulator, I would like to show you the Sawyer. The Sawyer robot, probably you already know about the Sawyer, but was from a company that is called Rethink Robotics. But Rethink Robotics was closed a couple of years ago. And it was bought by a German company, it's called Haas. And this company, they have relaunched it again this year, this Sawyer in a black version, they call Sawyer black version. And then, yeah, so that's, I don't know specifically if they have changed anything. It looks like the same thing, but I don't know if they have improved in some way or it's just a different way of targeting the market. In any case, what we have here, it's a robot that has some perception to identify the obstacles already. It has also perception on the wrist. So it has a main perception for obstacles, for a laser on the top of the head. Then it has a visual perception on the wrist. Then it has a gripper also. And what is more interesting is that the way that you can teach the robot to do the things. So you can program that with ROS, okay? But their main advantage, their main selling position is that you don't need even to program in order to make the robot do some tasks. So you can teach them in a very simple way by using those buttons that you can see on the arm. So this one is also basically used for teaching, research, or third-party solutions. When you want to create a small chain in a small factory, in a small company, so you can bring that robot and do it. So basically those are the robot manipulators that I wanted to show you. I don't know if I've missed any. Of course you are free to correct me if you don't agree on some of them, or you consider that I have missed one, like somebody was suggesting the hamster before. Then let me see if there is any questions here. I see that Mark Keller says, does ROS support LiDAR or is this additional software? Yeah, so LiDAR is a specification for a device, a sensor device. So LiDAR, maybe you have a Hokuyo LiDAR or a SICK LiDAR or another company manufacturer LiDAR. Then ROS has some drivers for those, for some specific LiDARs. Then if you want to know if your LiDAR has a ROS driver, so you can read data from the LiDAR by using the ROS topics, for example, then you have to check before in advance. So SICK, I know that SICK LiDARs, they do have, most of them, I don't know if all of them, but most of them, Hokuyo also. And what I would recommend you is that you go to an online shop that is called ROS Components. ROS Components is an online shop that they sell you LiDARs and other stuff. And everything that they sell there is certified by themselves that it supports ROS. So you have a driver. So that would be my answer for you, Mark Keller. Then let me see. Oh, it's lost again. Okay, so I don't know what happened. I hope that everything is running again. No, not yet. Okay, so yeah, sorry. So what can I say? So, and also I'm here talking, and I start to feel the passion, about explaining everything, and then I get completely lost about the quality of the transmission, and so, ay, señor, we have to think about this and make a better option. But anyway, so this is not your fault. So let's continue, guys. So let me check if I see any other question. No, okay. So let's continue then with the other options. So now it's about mobile manipulators. Mobile manipulators are robots that combine the manipulation with the mobile base in some sense. So they can go to the place and then do grasps. This is let's say the final frontier of robotics. If we achieve to have a robot that can go to the different rooms and clean everything, or bring us the coffee, or bring us the beer, or this is the final frontier. So this is where the most interesting research is being set up. And I would like to start with the RB Kairos mobile base, which is from Robotnik company. You have seen other robots on top, and from that company. And basically they have created a mobile base based on the Summit XL, something similar, improved, and they have attached a universal robot arm on top. And that's very interesting. We were using this for our live course that we did 2 weeks ago here in Barcelona, and where we teach about how to program mobile manipulators. And we were using this platform, and then it was very, very nice. It worked very well. Yeah, that's a very big thing, it's like this. It has an UR5 robot, so that means UR5, universal robot arm number 5. That means that it can it can carry up to 5 kilograms. So very, very nice. And in the same line, more or less same line, is this MMO by Robotics that also I shown you the base on the previous slides, and you can see that the base here is at the bottom. So this trend about combining the bases with the arms, this is a universal robot arm also, is the same thing. So basically those are very expensive robots that you can buy, but they are used mainly for research in projects, or for example in competitions. Also I will consider robotics competitions also as research. Then I wanted to start now with these more humanoid shape robots with the TR2 by Slate Robotics. The TR2 robot is a robot that it is 3D printed. So everything is 3D printed, and its aim is to provide a mobile manipulator with a very low cost. So in any of those, of the ones that I'm going to present here, that I'm presenting on this section about mobile manipulators, this one is the cheapest one. And it's because of that price, then it's also used for learning. So some people, they do buy for learning themselves, because they can do then grasping and navigation around the area. So this is a very nice option if you are short in budget, but you want to move into this world of mobile manipulators. Then what else? There's an RB1 by Robotnik. It's another type of human shape robot that so it's also for research because it's very expensive. And what they do is that they use one of their bases, the RB base from Robotnik. Then they attach this torso that can go up and down, and then they attach one arm. In this case, it's a Jaco arm. You remember that I mentioned the Jaco arm at the beginning? So this is the Jaco arm from Kinova. And then they add the perception on the head with a Kinect type sensor. So yeah, so this is one of this type, but I'm going to present you two more of this type of robots. Is the Tiago from Robotics is on the same line. So you can see that they are using here the base, the mobile base. They are attaching their own arm. So Robotics has constructed their own arm, and also this kind of accordion mechanism that allows those robots to grasp things on the top and also on the ground. And then the 3D perception. On the same line, we have the famous Fetch robot by Fetch Robotics, of course. And I would say that this one is the one that started all these type of robots and has the same characteristics as the previous two before. Yeah, so they have the laser for navigation, then the arm, the 3D perception, and this accordion style thing. So the Fetch, yes, and all the other three, they are for research, mainly used for research. And that would be my list of mobile manipulators that you can buy that are based on ROS, that you can directly switch it on and start working with ROS. Any questions related to that? Let me see. And then Lagan Kapoor says, let's do an R manipulator session again. Yes, so it could be, so you can propose that and send a proposal, for example, on the community here on the YouTube and see how much acceptance does it have. So usually when we receive proposals for sessions, then some of them they get accepted because people think that is interesting, so we do it. You can check our previous videos, which ones. So thank you for the suggestion, Lagan. Then have you covered, Jeffrey Pattinson says, have you covered any drone squads that are good for learning ROS? Okay, not about to, but I'm sorry you are going to be a little bit deceived, sorry, Jeffrey, but about to. So the next section is about drones, Jeffrey. Then let me see, Lucas Gandara Vega says, I'm doing my degree project with a Tatable 3 burger. What do you think it's about avoiding dynamic obstacles? So yeah, so that's a very nice robot. The thing is that it's very small, so it's very small you put it on the ground for avoiding obstacles of people moving around. Yeah, it can do it without any problem. Okay, so let's say that at the beginning. So it's just that it's a very small robot that is moving around and can do nothing, not very much. But if you want to use it for learning and doing dynamic obstacle avoidance, then you have already done this. It's inside the ROS navigation stack. So you had to learn, you had to understand how the move base works and how to use the different cost maps. So if you understand those things, then you will be able to use to make the Turntable 3 avoid the obstacles. I'm assuming that you have your Turntable 3 with a LiDAR on top, okay? You need that LiDAR in order to do this. Then let me see more questions here. We have Barat that says, any robot competitions you can mention that elders can participate? Okay, so elders, I don't understand what you mean elders, but I will assume that elders means 18 and above. Okay, so you don't worry about your age if you are 18 and above. Everything is available to you. So then in that case, then of course, any competition, you can go to the RoboCup. RoboCup, it's an amazing competition and it has different sections. It has different sections or that they are concentrated on different subjects. For example, there is one that is about RoboCup for soccer. So the participants, they have to build a team of robots that play soccer. Then there is another one of, for example, of RoboCup Rescue, which is about making robots that can get inside a disaster area and then rescue people, rescue stuff from there. And some of them, they are teleoperated, so they need a teleoperator on there. That's very interesting also. There is RoboCup at Home that uses robots. This part of the RoboCup is about making the robots work at home and do tasks at home. So in all of them you can participate, of course. Then there is, for example, now the the open source robotics foundation, the open robotics, I think it's involved in the subterranean challenge, for example, which is a competition in the States that is being running right now. I don't know if you can get in now. And then there is another one that is called the 1B competition, which is about robots on the water. 1B, and check for those. But in any case, so any competition that is for 18 above, you can participate. Don't worry about your age. It's not about your age, it's about the subject that it's been done there, if it is interesting for you and you can provide some insights there. Then Francois Genet says, we mean we lost the end of the low-cost arm manipulator just after the Crane X7. Oh, low-cost arm manipulator, you lost it. You mean after the Crane X? Nereo, you mean this one, Nereo? This one? I don't know if you mean this one because, okay, so this is not, let's say, not low cost. The lowest cost is this one. So Nereo is an acceptable cost. I mean, acceptable. I'm talking in the range, okay? So the cheapest one is this one, then this one and Nereo, they are more or less the same. And those one, they are very expensive already. So, I mean, expensive, I mean that they cost a lot of money. I'm not saying that they are not worth it. So, because expensive it depends on how you say. So for the Nereo one, it's very cool. This is a very cool one that you can have on your site. I don't know if this is the one that you were asking me. I hope it is. Then what else? So for the drones, let me go for the drones. So the drones, the only one drone that I could find that it's running with ROS is this one, the Gapter by Gaitech. And it's a Chinese company, Gaitech. And I'm not sure if they are, so I'm not 100% sure if they are selling it right now. So I just put it because I didn't find any other better. So I see here that Lagan is mentioning about Erle drones. But Erle has closed this branch. So Erle was acquired by Accutronic, and then they closed this line of Erle copters. The Erle copters were super cool drones that were based on ROS from the beginning. So you switch it on, and then they work on ROS. That's amazing. Then they changed their business line into something else, and then this line was closed. So you cannot buy Erle copters anymore. And then I have been checking about other drones. You can put some code on a Parrot drone that will make it, you control that using ROS. You can also put some code into DJI, DJI drones. But I mean, I haven't tested, I haven't seen it. So, and I don't know the state of really working state of that. So as I mentioned, I wanted to have something that I can tell you, hey, you buy this and then it's going to work for you for sure. For sure, let's say as much sure as I can be. Then for the Gapter, this was working with ROS, and in theory, they are selling this. I haven't seen any notice that they have discontinued, but also their website doesn't look very updated, so I'm a little bit scary. So I put this with some reservations from my side, but just to let you know that this one is working. So this is the only one that I have found that really works with ROS. I don't know if you have any other suggestion here on the chat, or you can. Then Francois says, we mean we lost the end of the low-cost arm manipulator just after the Crane 7. So that's okay, that's already answered, yeah. Can you go back to that? I think that I answered your question, Francois. Let me know if it's not answered. Then NASA recently advertised for the design of robots. Bruce, okay. What was before Franca is Lucas asking after UR5. So let me see. Okay, so after UR5, Yeah, okay, the Gen 3 by Kinova. So is this one. So we have here UR5, the next one is Gen 3 by Kinova that I mentioned in this one. So I don't know if it got caught it, but I mentioned that this one is about, so it's a very nice robot. It has a 3D sensor, kind of an Xsense, Intel Xsense, then Intel RealSense that is already attached by default. And then also you need to include another gripper from a third-party company. Yes, so basically that's the one from Gen 3 by Kinova. Let me see. Yeah, Francois, yes, you went back too fast. Okay, sorry, Francois, but I answer. Okay. Then Braham says, I have a Parrot Bebop 2, one in competition. Can I use ROS on top of it? Yes, so you can use ROS on any device. You can use. The only problem is that is there a driver that it's already made by somebody else and put it on that you can just download and then connect? Then if it is like this, then it's okay. If not, then you will have to ROSify that robot. You can ROSify any robot. ROSify a robot means that you add this extra layer of ROS and you control the robot by using ROS with your extra layer. How do you do that? By creating a node that this node contains two things. First one, on one side has the connection to the API of the robot that you bought. For example, the Parrot Bebop 2. So you connect this. And then on the other side, you have ROS topics. So this node is receiving the topics for the commands or for getting sensor data, and then it's translating that into the API that you can program the robot. So you can apply this principle to a DJI robot, for example, if you do it, but maybe you will have to do it. For the Parrot Bebop 2, I heard something about a ROS driver, but I don't know the current state of that. So search a ROS driver for ROS for Parrot Bebop 2, and you can see if it exists. And says, are there any competitions for drones? Okay, no idea about that. Any specific competition on ROS for drones? I don't know. I know that there are many competitions on drones, but not in our... Okay, so okay, sorry. Now I think I get your question better. And it's... so you mean like in the same sense as the RoboCup that I was mentioning, yes? So I don't know. I don't know if the RoboCup, not that I am aware, does include a drone competition, and any other that makes you program your ROS, your robot, and you can use ROS or something else. I don't know. And then QS John says, do you know any airship? I don't understand. What is this question? Sorry. Marcus says, I recommend Nirio 1, made in France. Yeah, already mentioned Nirio 1. Very, very nice one, made in France. And they do not support ROS 2. Okay, thank you, Marcus. So let's continue, and we are about to finish. So on the next, we have two sections more. One is for quadrupeds, and another one is for humanoids, with ledge humanoids. So for the quadrupeds, it happens the same as for drones. I was searching a lot, but I couldn't find any that works with ROS except for this one, DocBot, by the company Robotics. So I interviewed these guys for the ROS Developers podcast some months ago, on the last year. And they aim to provide these robots for research. So the people doing research on walking patterns and stability and control, they can concentrate on the algorithms instead of having to build and maintain this kind of quadruped. But the thing is that I haven't seen, it was supposed that they were going to release the first version at the beginning of the year, but I haven't seen that they are ready to sell yet. So I have included this one in this section because it's the only one that I knew that was close enough. So I know that, for example, Boston Dynamics has its own, but I talked to them directly and they do not work with ROS. So that's not the point for this presentation. But based on ROS, this is the one that I know. And still, I think you cannot buy. You cannot buy yet. So this is my section for quadruped, and then let's go for ledge humanoids. Those are the most expensive ones for obvious reasons. And the first one that I want to show you is the Robotics OP by Robotics company that I have presented already several of the robots. And this is a small human-sized humanoid robot, like this size more or less. And it's mainly used for learning and teaching. So it's very nice because you can start teaching and learning about walking patterns, walking algorithms, and this kind of control. Even if people use this for example, to create a team of soccer players, or for doing some kind of, katas and all that, so for fun. But you can use this for start learning and teaching about very complex subjects like robot locomotion in bipeds. Then we have the other ones that I'm going to present are two from the same company that is called Robotics. One is the RIM-C, which is a human-sized humanoid robot like this. And it's mainly used for research. What I'm amazed at is that about this robot is that it's running ROS, so you switch it on and then it's starting running ROS. And you have the working controllers on the inside, so you can control this robot with a command bell, for example, and move the robot working on several places. They have this version that contains 4 sensors on the feet, so you can use this information for creating other walking behaviors beside the one that comes with the robot itself. So this robot is very expensive and it's mainly used for research. It's not because of the expensiveness, but because it's also difficult to handle. So when those robots, they lose the power for whatever the reason, because you switch it off or batteries run out or some error happens, you have to take into account that they are going to fall into the ground because all the motors, they lose the power, so they go down. So it's difficult to handle that also. I mean, difficult. There is a solution. There is a crave. It's a crave or a crane? A crane. So it's a kind of a crane, so you have to be with a crane all the time in order to prevent those things. So that's why it's mainly used for research. And also here you can do very complex research topics, that is closer more to the robots that we would like to have in the movies, that we have seen in the movies, that we would like to have in our homes. So these kind of things, the robots cannot do it. So it's a very nice point where you can apply your research for that. And then they have built, apart from RIM-C, they have built a second version. Second version is a different line. It's called Talos, and it's even a bigger robot that can carry a lot more weight in its arms, but also they have included an EtherCAT communication network between all the different parts, all the control boards and the computers, so they can. So you use this robot, you can implement control systems up to 5 kilohertz of frequency. So that's a lot. Also, this robot has torque sensor in all the joints, so you can really make a torque control of all the joints of the robot, and then provide a better control instead of based on position, based on the actual situation of the robot. If it is carrying some weight, or is he suffering some forces from some place, from some circumstances of the robot. So basically those 3 are the ones that are humanoids that you can buy, and they work with ROS, supported by the company itself. So any question? Hostia, we lost again. Okay, guys, so I hope that is recovered. And the coffee, it's already cold because I have been talking here for an hour with the problems and so. You lost me at Talos, say speak them. Okay, so let me go back. So here it's Talos. I already has finished with Talos. What I was talking about Talos is that it's even bigger than Dream C, and that it's so they have it's a different line from the RIM series, and then they have included in the inside a communication bus that is based on EtherCAT. So this allows them to, so you use this robot, you can implement control cycles up to 5 kilohertz of frequency. So you can implement very, very precise and very fast control signals in this robot. Also, this robot is able to lift up to 6 kilograms, yeah? And also, it's interesting because it has again, okay, so I think that this is not the day, and yeah, so we are going to stop here with Talos because I think that the situation doesn't want me to explain more about this robot for whatever the reason. I don't know. So guys, let me know if you have any questions there on the chat. And before starting, just wanted to conclude that telling you, okay, so those are the robots that you had to buy in order to program them with ROS. But so where can you learn ROS in the first place? So that's a very good question, guys. I'm glad that you asked me. And of course, I'm going to propose you that you go to our online academy, especially on those days that in many countries around the world, we have to be enclosed in our homes and we have to work from there, or we have to dedicate the time to something. So that's the best option for you guys to go to our online academy, which is called the Robot Ignite Academy. Let me open the link and then you will see that there is a, let me see if I can show you here the screen properly. Okay, so let me see, is this one? So yeah, so in this academy you can see that we have a lot of courses, different courses for learning ROS, starting from the basics or going to more advanced topics like how to develop web interfaces for ROS robots, mastering mobile manipulators, ROS2 even. And for those that doesn't know even Linux or Python, and they need to start learning those subjects before, so we have created a Linux for Robotics and a Python 3 for Robotics course that are completely free. So you can start going and get up to date, so then later you can attack the ROS Basics course. We have other courses here about NVIDIA Jetson, autonomous vehicles, deep learning, OpenAI, many courses. So you have here a complete list, and you can check for manipulators, industrial robots. Have a look and let me know if you have any question related to that. And from now, so that's all from my side. So guys, let me know if you have any question there. I'm waiting for your questions. And then Marcus says, amazing and comprehensive overview of available platforms. Use overview confirms about experience and knowledge of the construct. Thank you, Marcus, for your words. Thank you very much for your support and your nice words for us. Thank you very much. Then Lagan Kapoor says, we want to learn ROS too as ambassador again. Oh yeah, so that was what Lagan is mentioning, is about the ROS ambassadors program that we had in the past, where so we created this figure that was the ambassador of ROS, and then the ambassadors were able to learn about the ROS subjects in our academy for free, but they had to deliver some presentations and so on. We canceled that because we didn't have so much interest from the other people. So only for the people that wanted to learn, you know, but we needed to expand that. So maybe we'll consider that in the future. Then Pigtem says, thanks for the very broad overview, brilliant. Okay, thank you very much, Pigtem, for being here. J. Carroll, James, thanks for helping me a lot. James, are you James from Clarkson University? Then we have Mark Keller that says, thanks for the information, my pleasure, Guru. Size of robotics OP, which one is the size? Okay, yeah, so it's like half a meter. So it's a small robot that you can have on your desk. Okay, so connection lost while I was explaining to Guru Srivastava that he was asking me for the size of the robotics OP is about half a meter, something like that. You can have it on your desk. You can have it here and do your experiment here. And then Braham says, thanks for the information. I am from India. I want to know any robotic community that I can join. Oh, yeah, then there are many robotics communities. So, of course, I will tell you that you join the community of the ROS developers by going to the ROS Development Studio. If you go there, then you will see that there we have a community and you can ask questions. Also, I would recommend you the official ROS community made by the creators of ROS, which is the ROS. You can find that on the ROS wiki. So if you go to ROS wiki, then you have to look for the discourse community. So I would recommend you that to go there. There is a lot of people there. And let me think about another one. About the cost of the robotics, so about the cost of the robotics OP that Burugu is asking, it's about around $2,000, around there, $2,000. And then what else? Lucas says, UR5 Panda or Gen 3 from Kinova. What arm will be best for R&D? Wow, I don't know. So I can tell you that it's a safe bet. So they have been tested, they have been used a lot. They have recently released this driver officially from the company. They have released that in last October. So until then, you could use UR with the ROS, but it was kind of handmade driver that was not maintained, so on. But now, since October, so Universal Robot has started to provide this support. Then I know that Gen 3 is pushing a lot into making the robot available for many people, and also especially for education. So you mentioned for R&D, I should know for which purpose, but I think that all of them, they can be good for you, any of them. You have to take into account two things more in order to decide. First one, about the perception. So which kind of perception do you need in order to do your research? So the only robot that has a perception attached already is a Gen 3. But is that good enough for your case? Or is that what you are looking? Or maybe you need some extra perception from the external environment. So this is something that you have to take into account. It depends. So maybe you need external perception, so that the Gen 3 has this camera on there is useless for you, maybe, I don't know. Then another thing is about the type of gripper that you are going to use, because if you are using armed robots, I suppose that you want to do some action, not just move the robot over there. I presume in 90% of the cases that's going to be. So you have to consider about the gripper also. So do you want to deal with different types of grippers? Then maybe Universal Robot and Gen 3 is better, so you can plug different types. You don't want to, you just need a gripper and you don't want to care about anything, then maybe Panda is better because it's already integrated. So you had to answer those questions before deciding. About the quality, the only one that I have seen, let's say, deeply is Universal Robot, is the only one. Then I have seen also the Panda, the Gen 3, but not much, just in some conferences, that's all. And Panda, never seen it live, never seen it in here, side by side. So that's what I can tell you, Lucas. Think it's possible to tell the cost of the robotics IP. I think that I already answered that. I don't know if you missed that. It's around $2,000. Then thanks, request sent to join community in Facebook. Okay. Quinoa is also okay, but so costly. Yeah. Okay. Yes. Then Lucas, UR 5 is 6 degrees. Panda is 7 degrees of freedom. Okay. Yes. Okay. So I didn't remember about that data. Great. Then you are 7 degrees to. Okay, so for that specific things, you have to go to the specifications of the robot themselves and see also the reach. So that you have to take into account many things. So also the reach area that you want to cover with your arm, for example. So go to the specifications and check all this information. Then it's not only about the price, you know, it's about what you need and which one covers your needs. We can add perception to UR also, and they have all things working and tested. Yes, of course, you can add any camera. We used in this live class, this live course that we did for along 1 week. We were teaching people how to program mobile manipulators here in Barcelona, and then we were using Intel RealSense connected into an UR arm with a gripper and the gripper was from Schunk, the gripper from the company Schunk. So we put a UR arm with an Intel camera with a Schunk gripper, and everything was working together. So yes, that's possible. And guys, I think that we are going to finish here. It's been a lot of time with a lot of troubles, but I think that I provided a lot of information to you. Remember that you can see this video later and check all my errors and mistakes and so on, and let me know. So put on the comments below if you have any suggestion so that we can improve in this list. And so for anybody that sees the video also can go to the comments and see your point and see, oh, okay, so this guy that is talking, he forgot about our robot, or he didn't consider this, or a new version of this has been released. So please put it there on the comments so we can make this more useful for the future people that will see the video. And that is all. Thank you very much for all. I'll see you next week on the new live class, and we are going to practice on that time. So you have to come and you have to be prepared to practice, to use your ROS code and your practice with the simulations online and everything. Will provide you with a ROSjet, and so it will be a typical live class like usual using the ROS Development Studio. So I wait for you. Thank you very much for being here. See you next week. But until then, keep pushing your ROS learning, guys.